Yes. So, today, I mean, before starting, right, the module consisting of what is a design process, right? What is a design process, and what are the phases in design process? That is what is designed. I mean, discussed in module 1. Okay. So, what I'm planning is today I'm going to discuss about the basics of design process, that is definition of design process, as well as basics of design and engineering, right? And after discussing this, what I will do is that I will discuss at least 3 topics. I mean, the remaining topics, right? Detailing customer requirements, setting design objectives, all these are phases of design process, right? So all these are called as phases of design process, right? Phases of design process. So in this phases of design process, today I'm planning to complete three phases: detailing customer requirements, setting design objectives, and identifying constraints. So these 3 things I'm planning to complete, right? And the Monday's class, I will complete the remaining 3. So your first module will be over. And after that, we'll be discussing case studies based on module 1, right? Okay, we'll move on to the next. Fine. So today we'll be discussing about the definition of engineering designs and the design levels, as well as causes of, cause of failures in engineering design, right? Okay. In the last class, we discussed about the definition of engineering and design. Is it right? So the same thing, we'll be giving the definition on engineering design. So what is an engineering design? Engineering design is the process of devising a system component or process to design needs, right? So you are going to design a particular product, right? For that, you are creating a process. So that process, what it will do is that it will show that you will be able to create a product. With the help of this process, you will be able to create a product. That is what engineering design is, the process of devising a system component. So component means, say for example, you have a problem, you are doing a design, right? For example, a flow diagram. So in flow diagram, what you will do, you will divide the whole product into small components, right? And that then what you will do, what is the first component you will be going to do? I mean, we will be going to produce. What is the second component? What is the third? What is the fourth? That flow, right? You will be doing it. That is what the design, the high level design, right? So what you will do is that you will identify the system component and you will make a process of it, right? That process, what it will do, it will help you to design, or it will help you to develop the product, right? So engineering design is a process of devising a system component or a process to design needs. Okay, that is what your engineering design. Okay, so it is an iterative design making process in which basic sciences, mathematics, and engineering sciences are applied to optimally convert resources to meet the stated objectives. So it's too lengthy, no issues. Let me tell you what is that. You are doing some repeated process, right? Why you are doing the repeated process? To get the requirements from the customer, to get the actual requirement from the customer. Okay, so what you are doing some repeated questions, you are asking repeated questions, you are doing so many repeated process to design a process, right? To design a process. How you are designing the process? With the help of science, mathematics, and engineering sciences, right? Basic sciences, mathematics, and engineering sciences, right? You are doing some repetitive process, and finally what you are doing is you are designing to reach or to achieve a stated objectives. For example, let me say, I am the client, right? I am asking the customer, I am asking the what is that designer, right? Okay, I need a table. Okay, so what the designer will do, he'll be asking question: what table do you want? whether it's a wood table or a glass table. What is the thing? Material, he's asking. I'm telling, okay, wood table. What is the size of the table? Whether 6 person can sit or 5%, 4% can accommodate, right? So I'm telling, okay, 6% can accommodate. So likewise, he is putting so many questions and I'm giving the answers, right? So what he is telling, he is having the idea of basic sciences, mathematics, and engineering sciences that is applied to optimally convert the resources to meet the stated objectives. So what is that convert resources? So he is having the resources to do the product, to make the product. So he is asking, the designer is asking the client or the customer, right? Okay, which material do you want? He is telling wood. Okay, he is thinking, okay, wood is already available. Right? Wood is already available in our company. Okay, we can do it, fine. So idea behind this is that with the help of iterative process and with the help of minimal resources, you are trying to develop a product. For that, you are making the design. Okay, for that you're making the design. So how the design is made? With the help of iterative process. You are doing some repetitive process, right? Fine. This is what your definition of engineering design. You are doing some design. You are doing some design with the help of some requirements, right? Okay. So now there are some design levels, right? Let me come back to the definition once again, once discussing these levels, right? Okay. There are some design levels, right? Adaptive design, development design, and new design. First, you should know what is an adaptive design. So adaptive design means the design is already available. Say, for example, design is already available in the sense, for example, say the client is asking, okay, I need a cycle. I need a cycle. Okay, customer is selling, okay, sorry, the designer is selling, okay, fine, we can able to design. What is the idea behind this design? Design is already available. Bicycle means what? There will be two wheels, right? You have a chain, right? It has to connect to both the wheels, right? You need to have a pedal, right? It has to be pressed. That's it, right? Some basic designs are already there. Only thing is the look and feel is going to change. So that is what is called as adaptive design. The design is already available. If he is coming and asking for the design, if the client is coming and asking for the design, okay, fine, the design is already available. He can show the design. The only thing is the outer, the look and feel, right? That you can show it with the help of, say, 2D or 3D animations, right? So that is what is called as adaptive design. You are adapting the design from somewhere else. You are adapting the design from somewhere else. Okay. Then the second one is called as development design. So development design in the sense, the design is already available, but the customer is coming and asking, okay, I need this particular change. I need this particular change. Say, for example, okay, take the same bicycle, right? Bicycle. I need a bicycle with 20 gears. With 20 gears. Then you have to focus on the design. Right? If he's asking for a TV, fine, it is okay. TV means, okay, normal TV, fine. Okay, I need a smart TV included with Android, Apple OS, Android OS. All the OS should be adaptable. Likewise, he is asking for a TV. Then we have to go for a what is that? Upgraded design. You have I have already the design, but he may be asking for a specific requirement. So you have to slightly modify the design. That is what is called as development design, right? And the third one is new design. From the name itself, you can able to understand new design means the design is not available in this world. It is completely a new design. It is completely a new design, right? So I think you can able to understand the three levels of design. Let me discuss the theoretical part of it. So what is adaptive design? Adaptive design is the process in which the parameters of the existing design or engineering device is slightly modified. That's what I told, right? Slightly modified to improve or suit a new trend in the market. Slightly modified means what? Only the look and feel you are going to modify, right? So to suit a new trend, right? Previously in older days, in my youth days, right? A cycle which is having, right, a different handbar, right? Nowadays, right, slowly it is evolved. It is actually in a straight handbar, right? Right, and the design is totally changed. Okay, so they have slightly modifying the look and feel. That's it, right? to suit the new trend in the market. Okay. And the next point is, in this process, the designer makes a minor modification in the existing design and form new member without changing the existing structure of the product. Right. So you're telling us, okay, this is a new trend, right? New trendy cycle. That's it. Right. They are telling that, okay, this is the existing structure. With the help of the existing structure, they are showing a new trendy model. That's it. Okay. The adaptive design does not require much knowledge. Please keep this in mind. The adaptive design does not require much knowledge or skill. If a person is already making a cycle, right, the same skill, they can use it. The same skill, they can use it, right? So the adaptive design does not require much knowledge. It can be done by the designer of ordinary technical training. Okay. So the examples are, as I told, designing of a bicycle, a mechanical watch. It's a good example. Mechanical watch, right? Mechanical watch. The watch actually is going. Every watch is showing the same time, right? Same kind of time, right? The only thing is the look and feel, the design. Some watches are very big, some watches are very small, right? So likewise, that is what is called as adaptive design, right? The second one is development design. So development designs also start from the existing design to bring a new idea. To bring a new idea. That is what, for example, say smartwatch. You can say smartwatch. Smartwatch is an example, excellent example. Smartwatch is showing the time. It is checking the heartbeat. It is checking how many steps we are actually walking, right? And you can able to speak. You can able to connect the watch with the mobile. So many features are there, right? So the development design also starts from existing design to bring a new idea. Okay, through the final product may differ significantly or moderately from the. So sometimes the final product may differ significantly. You cannot compare the smartwatch with the normal watch. So right, normal watch will be showing the time, maybe the date, for example, right? But the smartwatch showing having everything, it is completely different, right? So with the existing design, it may differ significantly or moderately from the existing design. Okay. So the next point is, in development design, the design engineer uses the working principle of one machine to another machine, right? The development design, right? The design engineer will use the already available working principle of one machine, and then he will be trying to implement or design another machine, right? So that will come to a new product, right, which may possess good quality working or size or whatever it is, right? Development design demands considerable knowledge and design ability. See, very important. So development design demands considerable knowledge, right? So if he is going for a smartwatch, then he should know about the electronics things, electrical things, mechanical things, everything he should know, right? So he should know considerable knowledge and design ability, right? Example is here combining the principle of bicycle, right? Combining the principle of bicycle to a next level of bicycle, no? Then develop motorcycle, right? Motorcycle maybe with different kind of disc. So many things are there. I don't know about it. Manual gearbox of the car, right? To be automatic, right? So the gearbox of the manual is converted to automatic, right? So such changes are there. All these are coming under development design. Okay, all these are coming under development design. The third one is new design. This is also called innovative design. Innovative design. When the designer develops something that didn't exist before, the design is called as new design. That is what I told just now, right? New design means the design does not exist. There is no existing design, right? You have to create the design, which is called as a new design, right? Only few members of the design fall into this category. Only few members. This type of design requires a lot of research work and maximum creativity, right? So because you have to get the product. So to achieve that particular objective or a product, you have to work a lot. You have to do a research, and you have to go for maximum creativity, right? So for example, first airplane, okay, first airplane. Okay, now recently in Mars, they have flight a helicopter, right? So that is also a new design, because in Mars the environment is completely different, right? Only 30% of the gravity is available in Mars, right? So such environment, it is actually a new thing. It is actually a new design, new thing, right? So this is what is called as new design. Okay. Now let me ask you a question, right? Uh, Let me ask you a question. What are the problems? I have explained you three levels of design, right? Okay, three levels of design. Can you please tell me what are the problems you'll be facing, or what are the problems if you are not properly designing a particular product? I'll repeat the question. If you are not properly designing a product, what are the problems you will face? If you are interested, you can unmute yourself or you can type in the chat. Accidents won't be efficient. Okay. Accidents, very good, Yusuf. Accidents, it happens because if we are not properly designing means in either way. Okay. Yes, of course, Abhishek. Safety is also okay. Then, so for example, I'll give an example. I need a watch. I need a watch, right? That watch uh, should have a facility of holograph. Anybody else know about holograph? Customer satisfaction. Very good. Yes, that is also a point. Okay, holograms. Fine, holograms. Okay, I need a watch. I am a customer, right? I am coming and I am asking for the design. I need a watch. That watch should be able to show the hologram of it. Say, for example, if I am communicating with the what is that destination, right, through phone, I have to see the hologram of that particular destination, right? Or if I am browsing in the internet for something, I have to visualize the hologram of it. For example, I want to see, okay, I want to see the types of dinosaurs, right? In the watch, I'm typing and searching, or just I'm telling what are the types of dinosaurs. It has to display a hologram. Okay, if such thing is there, is the design is already available? No. The Apple is actually they are doing the design, they are doing the research. Still, the design is not finalized. They are doing many prototypes. They are doing many prototypes. Okay, so likewise, if the customer is coming and asking for, say, which is not available, the design is not available, right? Then if you are going for a new design, then everything should be properly analyzed. Whether you have the resource to develop the holograms, whether you have the technology to design, whether you have the technology to develop, right? So all these things you have to check it out. Simply, okay, we will do that like that. If you're telling and if you're starting this, it is going to be a failure, right? So the resources, requirements, all these things should be available. Is it right? So when you are doing the design, before that, you should ensure that the resources and requirements are already available. Okay, let me see. What are the problems? Right? Let me see. Fine. Process of failure in most engineering design. First thing is incorrect and overextended assumption. Incorrect and overextended assumption, right? So he may be asking for a watch. I need a very new watch. Okay, suddenly the designer is telling, okay, I'm going to design a what hologram based watch, right? It is going to design within 3 months or 4 months. Not possible, because you have to do so much of research to achieve this. But it is possible. It is possible. Hologram is possible. All the theoretical and simulated results are successful. Practical research, they are doing the research. So incorrect or overextended assumption. That is the first failure, right? Poor understanding of the problem to be solved. If the requirements are not understanding clearly. So if the designer, right, he didn't understand the problem clearly, right? So then he won't be able to design the thing correctly, right? That's second failure. The third failure is incorrect design specification, right? Incorrect design specification. So if the specification is incorrect, the design will be also incorrect. Okay. And faulty manufacturing and assembly. If there is a problem with the design, right, what happens now? Your manufacturing and assembly will be also faulty. Okay. Errors in design calculations. Okay. And incomplete experimentation, errors in drawings, inadequate data collection. So all these are the failures. So if such kind of failures are there in the design, then your product won't be correct. The product won't be clear, right? So these are the causes of failures in most of the engineering designs. Okay, fine. And so the next topic is actually your phases of design process. Okay, so let me take that. Okay, so we have just completed the basic definition and the introduction part. So let us move on to the phases of design process. There are 6 phases. Okay, there are 6 phases, as I already told now. Okay, so we'll try to complete detailing customer requirements, setting design objectives, and identifying constraints. So we'll start with detailing customer requirements. Okay, so identifying and detailing customer requirements. Okay, so what are those? Okay. So identifying and detailing customer requirements. So client request. So what the client will do is that client may submit a request for developing a product artifact. Okay, the customer need should be expressed clearly. Okay, the client may know only the type of product that they need. Okay, he's coming. The client is coming. So the client is coming and asking for a particular product. Okay, he's telling that, okay, I need a table. I need a table. He don't know anything about it. He don't know about the size. He don't know about the material, what material we can use, right? So he is coming and telling, I need a table. So what you can do, you can ask, what is your budget? What is your budget for designing this particular table? Okay, this is the budget. So based on the budget, we can able to do in 2 ways. One is you can use wood. Another is you can use, what is that? Glass, right? So like this, you can give options to the customer, and the customer will be giving or expressing, okay, I need this. I need this. Okay. The client may know only the type of product that they need. For example, sometimes the client, okay, I need only wood. I need only wood, but he don't know about the size. Okay. Then you will be asking, okay, fine. How many can sit in the table, right? How many can sit in the table? Okay. He'll be telling, okay, 6. So 6 means this size will be fine. This size will be comfortable. So for this size, this much of cost is required for designing the particular table, right? Like this, you can tell. So when you are doing the communication with the client, right, he will be coming with only minimal details. I need a table, likewise, right? So you have to put many questions, right? Based on the questions, you can get the details, right? So first thing is identifying the requirements based on client request, okay? The second thing is modification of an existing design. The same client, okay, he is coming, he is telling that, okay, I am having a particular brand or a particular product, okay, and I want to modify this particular product. So in such cases, right, what is the meaning? You are going to modify an existing design. Okay, you are going to modify an existing design. So client may submit a request for developing a product or artifact. The customer needs should be expressed clearly, of course. The same thing which we discussed in the last year, right? And the client may know the type of product that they need, right? So the thing is that everything is same, all the design process is same, but the thing is that it has to modify the existing design. That is, the engineer has to modify the existing design, right? So for that, he will be taking the he will be getting the already available product, right? With the help of the product, you can able to do the design. So what are the changes to be done? And for that, what is the design, right? So example can be, say, different coffee brands uses different flavors, right? Different coffee brands uses different flavors. That is a good example of modification of existing design, right? And the third one is, generation of a new product. Profit-oriented companies always do research to generate entirely new concepts and products so that they can rule the market. So, example, design variants of televisions with new features and build materials. Great examples I told, right? If you are going for a new product, then you have to do so much of research. Why you are doing so much of research? To get that product, and you have to invest a lot to attain that particular product. Reason is that if that is successful, then they will be the ruler of the market, right? So they will be the brainstormers of the market, right? So they can rule the market. So for that, they will do any kind of research. They will do any kind of research to achieve that new product. So design variants of television with the new features is an excellent example, right? Fine. So all these are you are identifying and detailing the customer requirements. So in three types they are telling. One is client request with the basic idea, client asking for modification of an existing idea, client is asking for a new product. So based on these three things, we are able to identify the requirements, right? That is, you are detailing the requirements. Then setting design objectives, right? So setting the design objectives, right? What are the design objectives? Conduct feasibility analysis. First step is conduct feasibility analysis. What is this feasibility analysis? Four things are there: technical feasibility, economic feasibility, schedule feasibility, and social feasibility. Tell me, what is a feasibility first? Let us see. Let us discuss. What is a feasibility? Feasibility means see, for example, if you are doing a project next semester, right, you may be having mini project, right? So before starting a project, see, normally, right, since you are reaching the third year, you'll be having lots of ideas, right? As you have studied 2 years in the right for regarding the engineering, so you will be having too much of ideas, right? So you will come and approach the faculties, right? So before approaching anyone for with an idea, right, first you have to identify the feasibility. So feasibility means what? I think Shahana has told that convenience. Okay, Yusuf mentioned that they are able to eat conveniently. Yusuf, can you please make it clear? I didn't understand. Able to do it conveniently, right? Doing easily. Okay. Okay, somewhat okay. But anyway, let us discuss, right? So feasibility means, first thing is whether you are able to do it or not. Okay, okay. So think you can leave. Okay, right? Whether you are able to do it or not. The sense, nothing is impossible. It is possible. Everything can do it, but whether the company can be able to do it or not, right? So, for example, whether I'm having the resources to do it, whether I'm having the knowledge to do it, whether I'm having the money to do it, right? So all these are what? Feasibility, right? Feasibility means whether you will be able to do it or not, whether I'm having the knowledge, whether I'm having the money to do it, right? So all these are called as the feasibility, right? Feasibility, right? Let us see one by one. Technical feasibility, right? Conduct feasibility analysis. First one is what? Technical feasibility. What is technical feasibility? So technical feasibility is you have the requirement, and you have the you are going to do the design, right? So before doing the design, you have to do an analysis that for this particular requirement, whether technical feasibility is possible, whether technical resources are available, right? A simple thing is for holograms, I told you, right? Hologram based design. For hologram based design, say, what is that? Whether the particular person is having the knowledge to design the hologram, right? So technical feasibility, whether technical peoples are there or not. That is what technical feasibility. The second one is economic feasibility, whether it is possible to develop the design and the product with the help of the budget, So we have the budget with this budget. So with this budget, whether you'll be able to do this particular project, that is called as the economic feasibility, right? And schedule feasibility. So he may be asking, right, within 3 months, within 4 months, I need this particular product, right? We have to analyze the feasibility of the schedule, right? The schedule feasibility is very important, okay? And then social feasibility. Social feasibility means what? It should not harm the, it should not harm the society. It should not harm the society. Is it right? That is what we discussed in the last class. A science, any kind of science, what is that? Design or a science product, right? Should not harm the social. We should have that social responsibility. That is what the engineering and design definition is, right? So, for feasibility we discussed: technical feasibility, economic feasibility, schedule feasibility, and social feasibility, right? So these feasibility we have to check it out, and based on this feasibility you have to list out the objectives, design objectives, right? So initially what we does the customer requirements, then we have done the design objectives, setting the design objectives, right? And the third is we are going to do performing market analysis. While setting the design objectives, we have to perform market analysis. So what are this market analysis, right? Analysis, sorry, a small mistake is there. Right, a small mistake, no issues, right? So analyze the market, and identify the competing product and its exciting features, right? So analyze the market and identify the competing products and its exciting features, right? Let us say you have the requirements, and what you are going to do is you are going to design the particular project, right? So while designing it, what you have to do is there any same kind of product available in the market, right? Whether that particular product is actually successful, very successful. What are the features available in that product? That we have to do the market analysis, right? That is why analyze the market and identify the competing products. Identify the competing products and its exciting features, right? So we have to analyze all those things. Once analyzed, identify the supplementary feature. That is the better feature. Already the features are exciting features are available. So beyond that, any other excellent features are available. I had to identify that, and that should be included in the design. So that your market, you can compete in the market. Okay. So identify the supplementary features that may be expected from this product. Okay. The next objectives is documenting the finalized design product. Document all the finalized requirements or design objectives. The document act as an agreement between the customer and the manufacturer, right? So what we discussed initially, feasibility we discussed, and then we analyze the market, and finally we documenting it. We are documenting it. So that document should be an agreement between the customer and the manufacturer, right? That is what is called as system requirement specification. That is SRS document. Normally in industries, right, they will tell where is the SRS document, right? Where is the SRS document? That is system requirement specification, right? In automation industry, right, it's robotic process automation. They will tell that PDD, product design document. That is what is called as PDD. So here it is system requirement specification, right? So likewise, some specification document is there. It is called a system requirement specification. Okay. So the finalized designed objectives, right? That should be documented. That document should be an agreement between customer and the manufacturer, right? Excellent. Fine. So now what we discussed is that we have discussed the design objectives. We have discussed the customer requirements. How to identify the customer requirements, right? These two things we have discussed. Okay. So now we are going to discuss the design constraints, right? What are the constraints, right? What are the things which is stopping the design, right? What are the things which is stopping the design? That is what is called as design constraints. Okay, functional requirements, safety constraints, time and economic constraints, legal, ethical, and quality constraints, manufacturing constraints, right? And uh, ergonomically and aesthetic constraints, right? So these 6 constraints are there. Okay, let us start with the first constraint, functional requirement. Okay, functional requirement. So, what is functional requirement? Okay, these constraints impose a limit on the proposed working principle of the product. Okay, say for example, energy requirement, material used, and overall geometry. So, for example, say energy requirement is very important for this product. Energy requirement is very important for this product. Say, for example, battery constraints. If you are having, if you are asking for a product which requires battery is the most important, right? So, what is the life of the battery, right? Whether it will stay back for one day or 2 day or 3 day, that we have to list out, right? So before designing this, you have to check out the energy requirement of a product, and then materials used. So what kind of material you're going to use? What kind of material you're going to use? And then what is the size of it? Right? The product may be super product. You may be able to design it, but what is the size? Right? The size, if it is working perfectly, but if the size is very big, then it is a problem, right? So you have to take these constraints into account when you are designing the product, right? When you are doing the design, you have to take these constraints. What are those? Energy requirement, material used, and overall geometry, right? So these constraints impose a limit on the product proposed working principle of the product, right? That is what the thing, right? Nowadays, right? Mobiles is actually it is actually booming, is it right? So 10 or 15 years before, right? We were actually getting this mobile, right? Nowadays, without mobile, we won't be able to live. Everything is there in the mobile, right? What about the energy requirement? So you are buying a mobile for attending the class, right? Right. So what you are thinking is that continuously from morning to evening, yesterday morning to evening workshops were there. At what time? When we are going to charge the mobile, right? So you won't be getting any time to charge the mobile, right? So how much time the standby charge, say for example, how much time the mobile can withstand? That is a requirement, right? So your design for that product will what is that? We have an issue in energy part, right? That is, these constraints impose a limit. So it is limiting your what is that product features, for example, right? So it will impose a limit on the proposed working principle of the product, right? So because of energy, power requirement, because of material used, because of geometry, the size of the product, right? The second is safety constraints, very important. So these constraints impose a direct threat to the product, right? Direct threat to the product, right? One thing is that, or to the user, right? If the product damages immediately, right, it is a safety constraint, right? See, most of the mobile, right, suddenly when you bought and another 10 days, right, it got busted or it got damaged, right? So this is what is called as the constraint for product, right? A threat to the product or to the user, right? Operation safety constraints, environmental constraints, and safety issues due to inevitable human errors. So you have to take these constraints into account while designing the product. Okay. The third one is time and economic constraint. Right. Say, for example, a customer is coming and he's asking for, say, I want a vaccine. I want a vaccine within 2 months. It's not possible. Previously, right, if you want to design a particular vaccine, it may take 10 years, right? But nowadays, because of the new technology, right, we'll be able to design a vaccine within one year, right? Within 1 year, see, the vaccine came. But somebody is coming and asking, okay, I need a vaccine in 2 months or 1 month. It's not possible. That is time and economic constraints. Customer always expect quick delivery, right? Customer always expect quick delivery of the product within minimum cost. Within minimum cost. He may be demanding the product also leads to time and economic constraints, right? Demand of the product also leads, say, for example, vaccine, right? I told you, everybody needs a vaccine. So now the vaccine is not available, right? The sense we have to produce it. We are waiting for the raw material. So likewise, the demand of the product also leads to time and economic constraints, right? So because of that, your overall budget of the particular product may get increased. Okay. So time and economic constraints is major thing playing while designing the product, right? The next is legal, ethical, and quality concerns. Say, for example, take a food and safety, right? Say if you are designing a product that is a food product, okay. So what you should do is you have to get the approval from the government, that is Food Safety and Standard Authority of India, FSSAI, right? ISO is there, ISI is there. So there may be some quality controls and quality assurance agencies, right? We have to get the permission from the quality control and quality assurance agencies, right? So the end product should be approved by various organizations or quality control and quality assurance agencies to ensure its quality and safety. Okay, so that also you have to take that into design constraints, right? Design constraints, legal, ethical, and quality constraints. And then manufacturing constraints, right? The direct production limitations are due to equipment raw material deficiency, right? Equipment raw material deficiency, method involved in manufacturing, and labor shortage. So because of this, your product limitations will be there. You have to hire laborers, you have to purchase so many raw materials, right? Because of that, your budget may get increased. Methods involved in manufacturing, all these things are there, which is coming under the manufacturing constraints, right? And then ergonomically and aesthetic constraints. Products should be user-friendly, attractive, and visually pleasing. That is also a major thing. Even for food product, right? If the packing is not good, nobody is going to buy it. You have to give a good look and feel in that particular packet, right? So product should be user-friendly, attractive, visually pleasing, right? That is what is called as ergonomically and aesthetic constraints, right? So that's all. So these are the phases which we have discussed. What are those? We have identified the customer requirements with the help of 3 methods, right? And setting the design objectives, starting with your feasibility study, right? We have identified the objectives, right? And identifying constraints. What are the constraints when you are designing the products? So all these things we have discussed till now, right? So the remaining things we'll discuss in the next class, right? So let me do one thing. I will stop the recording. Yes.